Consider the following table, which relates a student's two-year college with their transfer admission status at UC Davis. Part A, if one student is selected, find the probability that the student was denied. We're talking about one student, so we should end up with just one fraction. The bottom is going to be how many different students can we pick from. That's just going to be the total of how many students we have total in our study here. So we'll just add up all the numbers and get a total. So adding up all the numbers here, we have 3 plus 17 plus 19 plus 5 plus 11 plus 7 plus 1 plus 16 plus 1. And we get a total of 80. So there's 80 different students we can pick from. That's going to be the bottom. For the top, we are interested here in the probability that the student was denied. So how many students were denied? Denied would be this entire column. So 17 plus 11 plus 16. 17 plus 11 plus 16. 44. Part B, if one student selected, find the probability that the student was from Delta College or was accepted. Keyword here is the word or. The bottom is going to be the total of everybody again. That's going to be 80. And keyword or means I want to take all the Delta College students and then combine them together with all the accepted students. So the way I usually do this is I will take all the Delta College, so that's 5 plus 11 plus 7, and then add on the accepted students, which would be 3, 5, 1. But keeping in mind that I don't want to include the 5 because I got the 5 already from the Delta College. So I'm just going to add on a 3 and a 1. Okay, bottom's 80. Up top, 5 plus 11 plus 7 plus 3 plus 1. 27. Part C, if one student is selected, find the probability that the student was from CRC and was denied. Keyword there is the word and. Bottom is going to be the total of everybody. That's going to be 80. And means that I want both at the same time. So I want the students who are from CRC and at the same time denied. And as a hint, ands should be a single number on a table. So CRC at the same time denied. So CRC denied. CRC denied. These 17. So these 17 students were from CRC and at the same time they were denied. 17. Part D, if one student is selected, find the probability that the student was accepted given that the student was from CRC. Okay, keyword here is the word given. So given means that we're going to be talking about conditional probability. So for these given problems, I'm going to use symbols. So in symbols, what I'm looking for is the probability accepted. Given is the line. Student is from CRC. So accepted, given, CRC. Now, the given part is telling us that we should focus just on the CRC students for the top and the bottom of the fraction. So for the top and bottom, we're going to focus just on the CRC students. In other words, ignore the rest of the table and just focus on the CRC row there. So focusing just on the CRC students, how many are there total? So total would be 3 plus 17 plus 19. And then we have a total of 39. That's the bottom. And then still just focusing on the CRC students, how many are accepted? So focusing still just on the CRC students, how many are accepted? 3. Part E, if one student is selected, find the probability that the student was from Sierra College given that the student was denied. So I see the word given again. So in symbols, what I'm looking for here is probability of Sierra given, denied. So anytime you have the word given, it's telling you to focus on just a part of the table. What are we focusing on here? So it's always the second one. So focusing just on the denied. Okay, so for the bottom, focusing just on the denied, how many are there total? So just on the denied, the total would be 17, 11, 16. 17 plus 11 plus 16. And we get a total of 44. Okay, and still focusing just on the denied, how many are from Sierra? So just the denied, how many are Sierra? 16. And again, anytime you have the word given, it's telling you to focus just on one part of the table for the top and the bottom. Part F. If two students are selected, find the probability that the first student was a CRC student who was accepted and the second student was denied. So now we're talking about picking more than one student. So we're picking two students here. So two students means we're going to have two fractions that are going to be multiplied together. So the first fraction, we want to be CRC student who was accepted. So the first student is CRC accepted. Second student, denied. Okay, for the first fraction, the bottom should be everybody. So everybody was, what's the total? 80. And then how many students or CRC students who were accepted? CRC accepted, CRC accepted, CRC accepted, 3. Now for the second student, keeping in mind that we don't want to pick the same student twice. So for the second student, because we already picked one student for the first lot, we do have to reduce the bottom. So the bottom's now just going to be 79 and then denied. Denied, it doesn't specify the college, so denied would be the entire column, so 17, 11, 16. 17 plus 11 plus 16 is 44, but sometimes we have to reduce. So you have to ask yourself, have we used any denied students yet? No. The first slot was an accepted student, so we haven't used any denied, so we should have the full 44. Okay, and the way you enter this into the assignment is 3 over 80, and then times, the times on a computer would be the star symbol, which should be shift 8. Part G. If 3 students are selected, so that means I need 3 fractions that are multiplied together. Find the probability the first student was a CRC student who was accepted. So first one is going to be CRC accepted. The second student was a Sierra College student who was accepted. So second one is Sierra accepted. And the third student was accepted without any college specified, so just accepted. First fraction, the bottom should be everybody, which should be the same as before, 80. And then let's go ahead and fill in the bottom for the rest of them. So because we don't want to use same student twice, for the next fraction, we should be down to 79 and then down to 78. Okay, so now for the tops. First student here, CRC accepted. How many are there? CRC accepted, 3. Second student, Sierra accepted. Sierra accepted would be 1. So anytime, so for the second, so anything after the first fraction, we have to ask ourselves, do we have to reduce? So for the second fraction, Sierra accepted. Have we used any Sierra accepted yet? No, right? The first one was a CRC accepted, so we have not used Sierra accepted yet. So we should have the full, we said was 1, so the full 1. For last student, accepted without any college specified. So accepted without any college specified would be the entire column. So the entire column would be 3 plus 5 plus 1. That's 9. Now, the question is, do I have to reduce? And the question we're going to ask is, have we used any accepted yet? And the answer is yes, we have, right? The first student was accepted, the second student was accepted. So we've used 2 accepted already, which means we have to reduce by 2. Okay, so the total was 3, 5, 1, that's 9. We have to reduce by 2. So this is going to be 7. Okay, so make sure you understand why it's 7 and not 9. Part H, if 3 students are selected, so 3 students, 3 fractions, find a probability that the first student was a Delta College student who was denied. So first student is Delta denied. The second student was a CRC student who was waitlisted. So second one is CRC waitlisted. I'll just write wait. Third student denied. Okay, let's talk about the bottoms. For the first fraction, the bottom should be the total of everybody. That's going to be 80. And then once again, we don't want to pick the same student twice. So when we go to the second student, we're down by 1 because we can't pick that first student again. So we're down to 79 total and then 78. First fraction up top, how many students were Delta denied? Delta denied is 11. Okay, and now for any fraction after the first, we have to keep in mind that sometimes we have to reduce. Second fraction, CRC waitlisted, CRC waitlisted, CRC waitlisted, 19. So is it 19 or do I have to reduce? So we ask ourselves, have we used any CRC waitlisted yet? No, right? The first fraction was Delta denied. So we have not used any CRC waitlisted yet. So we should have the full, we said 19. Last fraction, denied without any college specified. So denied would be the entire column. So entire column would be 17, 11, 16. And that's 44. So 44, or do we have to reduce? So the question we're going to ask is, have we used any denied yet? Yes, right? The first student was denied. So we've used 1 denied already. So we have to reduce by 1. So it's not going to be 44. It's going to be reduced by 1, 43. Okay, so make sure you understand why it's 43 and not 44. Okay, and that's because we've used 1 denied already. So we have to reduce by 1. For part G, when we're talking about accepted, we use 2 accepted for the first and second students. So we have to reduce by 2 there. Part I, if 3 students are selected, find a probability that at least 1 student was accepted. Keyword here is the word at least 1. So anytime we're trying to find a probability of at least 1 something, we're going to use the complement. So the probability of at least 1, here we're talking about at least 1 student accepted, so at least 1 accepted, is going to be 1 minus the probability none accepted. Okay, anytime we're looking for at least 1 probabilities, we're going to do it as 1 minus the probability of none. So what this means is we're going to do 1 minus none. We're talking about 3 students, so we'll need 3 fractions. So 3 students, none of them accepted, means I want the first fraction, second fraction, and third fraction to all be not accepted. So I'm going to be looking for not accepted, not accepted, and not accepted for all 3 fractions. So for the bottoms, it's going to be the same as before. First one is going to be total of everybody, so that's going to be 80. Second one, because we don't want to pick the same student again, we're down to a total of 79 and then 78. Now, for all three fractions, I want not accepted. So not accepted would be all the students who were not accepted. That will be the denied together with the waitlisted. So let's add all those up. 17, 11, 16 plus 19 plus 7 plus 1. And that's 71 not accepted. Next fraction, I also want to be not accepted. Okay, so normally that would be 71, but I already used one not accepted already, so we have to reduce that down to 70. And then the last one, I also want to be another not accepted. Normally that would be 71, but I used two of them already, so I have to reduce by 2, which means I'm down to 69. So your final answer is going to be 1 minus 71 over 80 times 70 over 79 times 69 over 78. Okay, so don't forget the 1 minus. So just type it in like that. 1 minus 71 over 80, and then the star symbol, 70 over 79, the star symbol again, 69 over 78. So the star symbol again is going to be shift 8. Part J, if 3 students are selected, find a probability that at least one student was from Sierra College. Once again, I see the words at least one. So this is going to be another one of those 1 minuses. I'm looking for at least one Sierra. Okay, so that's going to be 1 minus none Sierra. So this is going to be 1 minus, how many fractions do I need? I'm talking about 3 students, so I'll need 3 fractions. So 3 people, 3 students, none Sierra means I want not Sierra, not Sierra, not Sierra for all 3 fractions. Okay, the bottom of the fractions. For the first one, it should be the total number of students. That's going to be 80. And then once again, because we're not going to repeat the students, or we're not going to pick the same students again, for the next fractions, we have to reduce. We're down to 79 and then 78. For the top, I want not Sierra. So not Sierra would be all the CRCs and all the deltas. So the first 2 rows here. 3 plus 17 plus 19. Plus 5 plus 11 plus 7. That's 62. Okay, for the next fraction, I want to be another not Sierra, right? Because we already used one not Sierra, we have to reduce. So that goes down to 61. And then once again, the last fraction is another not Sierra, but we used 2 of them already, so we have to reduce by 2, which means we're down to 60. Final answer, 1 minus 62 over 80 times 61 over 79 times 60 over 78. Researchers collected data on students' class standing and how they did in their English class. Part A, if one student selected, find a probability that the student was a junior. So we're talking about one student, we'll need 1 fraction. For the bottom, it's going to be how many different students can we choose from. That's going to be just the total number of students. Total number of students is going to be 2 plus 4 plus 4. Plus 10 plus 19 plus 1. Plus 6 plus 7 plus 13. 66 total. Okay, that's the bottom. Up top, we're interested in probability that the student was a junior. So how many juniors are there? Juniors would be this entire row on the bottom here, 6 plus 7 plus 13. 26. Part B, if one student is selected, find the probability that the student was a freshman or failed. So keyword there is the word or, and we're talking about one student, so that's one fraction. The bottom is going to be everybody again. That's going to be 66. Now, or means we're going to take all the freshmen and combine them together with all the failed. So all the freshmen would be 2, 4, and 4. And then together with all the failed, which is 4, 19, and 7, 7. But remembering that I already got the 4 from doing the freshman. So I am only going to add on the 19 and the 7. And that's because I don't want to count a box twice. Bottom is going to be 66. Up top, it'll be 2 plus 4 plus 4 plus 19 plus 7. 36. Part C, if one student is selected, find the probability that the student withdrew given that the student was a sophomore. Keyword is the word given. So anytime you see the word given, it's telling you to focus on just a smaller part of the table. So in symbols here, we're looking for probability withdrew given sophomore. Okay, this is telling me that I want to focus just on the second part, which is the sophomores, for the top and the bottom of the fraction. Okay, so starting with the bottom, focusing just on the sophomores, how many are there total? Just the sophomores, how many are there total? So 10 plus 19 plus 1. That's 30. Okay, for the top, still focusing just on the sophomores, how many are withdrew? Or how many withdrew? So just the sophomores, 1 withdrew. Part D, if one student is selected, find the probability that the student was a junior and passed. Keyword and. So and, remember, means at the same time. The bottom here is going to be everybody, which is the 66. And I want the juniors and passed at the same time. So I want the students who are juniors and at the same time passed. And as a hint, ands will be a single number in the table. So junior passed. Junior passed, 6. So junior passed. So these are the students who are juniors and at the same time they passed, 6. Part E, if one student is selected, find a probability that the student was a freshman given that the student withdrew. Keyword is given. So I'm looking for probability freshman given withdrew. Okay, so anytime you have the word given, the bottom is not going to be the total of everybody. And anytime you see the word given, it's telling you to focus on just a smaller part of the table. So here, we're going to focus on the second part, which is just the students who withdrew. For the top and the bottom. Okay, so focusing just on the students who withdrew, which is the last column here, how many are there total? So 4 plus 1 plus 13. 18 total. That's the bottom. For the top, focusing just on the withdrew students again, how many are freshmen? So just the withdrawal students, how many are freshmen? 4. Part F, If 2 students are selected, find the probability that at least 1 failed. Keyword I see there is the word at least 1. So anytime I see the words at least 1, I know my final answer is going to be 1 minus something. So in symbols, we're looking for probability of at least 1 who failed. Okay, and the way we calculate at least 1 probabilities is we're going to do 1 minus the probability that none of them failed. Our answer is going to be 1 minus, and then how many fractions do I need? We're talking about 2 students. I'll need 2 fractions. 2 students, none failed, means that I want both the fractions to be not failed. Okay, for the first fraction, the bottom is going to be the total of everybody. The total of everybody is going to be 66. And then because we're talking about picking people, and I don't want to pick the same person again, for the second fraction, the bottom is going to be reduced by 1 because we already picked one person for the first fraction. For the second fraction, the bottom we're down to 65. And now for the tops. The tops, we're looking at the not failed. So not failed would be all the pass together with all the withdrawal. So 2, 10, 6. Plus 4 plus 1 plus 13. And we have 36. The second fraction, I also want to be a not failed. So because we already used 1 not failed, we have to reduce by 1 to 35. Okay, so final answer, 1 minus 36 over 66 times 35 over 65. Part G. If 3 students are selected, find the probability that the first student was a junior who passed, the second student was a freshman who failed, and the third student passed. So this one doesn't have the words at least 1, so this will be just regular 3 fractions. The first fraction I want to be junior who passed, so junior passed. Second student, freshman failed. And third student passed. Okay, first fraction, the bottom's going to be everybody. Everybody was, I think, 66. Okay, and then let's do the bottom for the second and third fractions. We don't want to pick the same student again, so because we already chose one student, we have to reduce by 1 to 65, and then again, reduce to 64. First fraction, I want junior who passed. So junior passed, junior pass, 6. Second fraction, freshman fail, 4. So 4, do we have to reduce here? And the question we're going to ask is, have we used any freshmen failed yet? No, right? The first one was junior passed. So we haven't used any freshmen failed yet. So we have the full 4. Last fraction, we want passed without any specification of their grade level. So all the passed would be the whole first column. So that's 2, 10, 6. 2 plus 10 plus 6. That's 18. Question is, do I have to reduce that 18? So question we're going to ask is, have we used any passed yet? Yes, right? The first student passed, right? So we used 1 pass, which means we have to reduce by 1 to 17. Okay, so it's 17 and not 18. Part H, if 3 students are selected, find a probability that the first student was a freshman who withdrew, second student was a junior who withdrew, and the third student withdrew. Okay, so this is not one of those at least ones. So this will be just the regular, talking about 3 students, 3 fractions. First one, I want to be freshman withdrew. So freshman withdrawal. Second student, junior withdrawal. And the third student, withdrawal. With no specification about grade. Okay, let's talk about the bottoms. Bottom of the first one should be everybody, which is 66. And then once again, because we don't want to repeat the students, when we get to the second fraction, the bottom is going to be reduced by 1 to 65, and then 64. Now the first one, the top of the first one, freshman withdrawal, 4. Second fraction, junior withdrawal will be 13. And the question is, do I have to reduce? So you should ask yourself, have we used any junior withdrawals yet? No, we haven't, right? The first one was freshman withdrawal, so we haven't used any junior withdrawal. We should have the full 13. Last fraction is just withdrawal, so just withdrawal without any specification about grade. Should be all the withdrawals, so that's 4, 1, 13. 4, 1, 13, 4 plus 1 plus 13, that's 18. 18, question is, do I have to reduce? And what we should ask ourselves is, have we used any withdrawal yet? Yes. First student withdrew, second student withdrew, so we've used actually 2 withdrawals already. We have to reduce by 2. So it'll be 18 reduced by 2 would be 16. Okay, so make sure you understand why it's 16 and not 18. Part I. If 3 students are selected, find a probability that at least 1 student was a sophomore. Keyword is the word at least 1. Okay, anytime I have at least 1, I know my final answer will be 1 minus some fractions. So we're looking for at least 1 sophomore. Okay, and the way we calculate at least 1 probabilities is it's going to be 1 minus the complement, so 1 minus none sophomore. So 1 minus, how many fractions do I need? We're talking about 3 students here, so 3 fractions. 3 students, none of them sophomore, means that I want them to be not sophomore, not sophomore, not sophomore. So all 3 not sophomores. So not sophomore, and not sophomore. Let's talk about the bottom of the fractions. The first one should be everybody, which was going to be 66. And then once again, we're going to reduce because we don't want to pick the same student twice. So for the second fraction, because we already chose 1 student, we're down to 65 total, and then we're down to 64. For the top, I'm looking for the not sophomores. Not sophomores are all the freshmen together with all the juniors. So the first and last row. First is 2 plus 4 plus 4, plus 6 plus 7 plus 13. That's 36. Second fraction, I also want to be a not sophomore. And keeping in mind that I already chose 1 not sophomore, I have to reduce by 1 to now 35. And then for the same reason, the last one, I also want to be another not sophomore. So I have to reduce again to 34. So final answer will be 1 minus 36 over 66 times 35 over 65 times 34 over 64.